All right. So a couple of things here. First of all, I posted up here, and I gave you a hard copy of the derivative rules. I don't remember when I did that exactly. Was that on Thursday last week? Was that? Hopefully you saved that, or you just typed it, or I gave you that hard copy. So maybe that was. Oh, I thought I put it on here. Well, I know it's another spot. It definitely is in documents. Thank you. So under documents, I thought I put it on one of the places. And I haven't really went to this very often, but I do have a bunch of them here, and they're kind of organized. Here's chapter 1, chapter 2, and we're in chapter 3 right here. So the assignment sheet, and these are the answers. I guess I could have told some of you that if some of you that took those. But anyway, that was back when we did that matching thing. But here's the derivative rules, and so as we go through this, just your sum rule, when you multiply by something, the product quotient, hopefully those aren't things you really need to study, the chain rule, and then all these rules with, the power rule, e to itself. But the ones with the stars by them are the ones that I just put that there because it's like, hey, we don't run into those that often, and you might do 2 gateway tests and never see a 2 to the x or whatever, and then all of a sudden it shows up on the third one, right? And you forgot to go back and study. You were just looking, because oftentimes what people do, let's say we take this one on Tuesday, probably go over it in class on Wednesday, and then that'll be the last we do spend talking about class time on the gateway test. But then if you come in, take number 2, a lot of times people want to come in and see what they missed, or come in the morning and see what they missed, and you kind of review those. And sometimes I think that's all people do. They look at what they missed on that one. Okay, I'm ready. Let me take the next one. And, without going back and looking over these. So be careful of that. So you got this rule, you got the log rule, and then sine, cosine, of course, we're so used to, but maybe we forget about tangent is secant squared, or cotangent, or the ones up here, secant, cosecant. We don't run into those that often, but you are responsible for them. And then the arc, sine, cosine, and tangent rules as well. Okay? So those are the ones that will be on there that you do need to know. All right, and if you go under the web links, I've added a third one here that's a lot like the second link. This is from Jacksonville University. Math 140 is their Calc 1, and Math 141 is Calc 2. And so here's the tests, and here's the solutions. So test 1, and the nice thing about these is these are more of a mixture, like that derivative practice number 2. That one is, it starts out easy. The first one's pretty easy ones, and it gets a little harder. It's got some implicit. Now, what I don't know is if this one has any implicit differentiation on it. It doesn't look like it does, and they may not include implicit differentiation in theirs. So at this university, it looks like they have 8 questions, and they have to get 7 out of 8 to pass. So that's what it says here. No partial credit. That's kind of what we've talked about. It's either right or it's wrong. So pretty simple one to start with. A pretty basic quotient rule here. You got a chain rule inside of a log. You got an inverse trig. Here's a 5 raised to something, so that's that exponential one. Here you got another chain rule one. Here you got a product rule, and here you got one that probably not a quotient rule. That'd be a -1. That's pretty simple. Geez, I'll go to Jacksonville. That seems like a pretty easy one. Let's go down here and see if they get any harder. Still good practice, because if you can get all those, here's a product rule. Here's, again, not too bad. I'm not sure what the deal with the decimals are, but they got some of those. So those are good ones to do. I mean, I think you should. Of course, you got to get 7 out of 8 too. So it's a little higher bar than 8 out of 10. So anyway, that's pretty good practice as well. I mean, those aren't totally easy ones, but some of those are a little easier than some we're doing on page 195 too. All right, questions? Ones you want to look at, ones you did off the website, ones you did off of the any of the websites or the page 195 or any that you want to ask about, kind of last chance. Yeah.
On the website, the derivative number 2 from that site you were just on.
Yeah.
Number 8.
What do you have the problem
Yeah, I have it.
for me?
Y equals all in parentheses squared, and then there's a division, fraction. Cosine of x over 1 minus sine x.
1 minus,
Sine x.
like that. Okay. Now, anytime you have a fraction squared, you could square the top and square the bottom. I don't know that I'd recommend that necessarily. I mean, you'd have cosine squared on top. I mean, I don't envision, I mean, when I first look at this, I think about maybe doing some things I could simplify it first. That might make life a little easier. I don't anticipate giving you anything like that. You know what I mean? Where you're going to simplify. So I don't want to make a big deal about doing that. Because there's all kinds of things you could do wrong when you simplify this. You could square the top. The bottom would not be 1 minus sine squared. It would be 1 minus sine all squared, right? You'd have to FOIL that if you wanted to. Now, I wouldn't FOIL it. But the nice thing about that is, what's another name for cosine squared? That is 1 minus sine squared, right? Which is 1 plus sine, 1 minus sine. And then the bottom would be 1 minus sine all squared. So you could cancel one of those with one of those, right? The whole thing would end up being 1 plus sine over 1 minus sine, which is still a quotient rule, right? You'd still have to do a quotient rule and stuff. So I don't know that I really saved myself anything by doing any of that, right? But I looked at that, and that was one of the first things that came to my mind, just thinking of that. But again, for you guys, not really going to be anywhere you have to first do some algebra to make it simpler, whatever. And you don't have to anyway. Even if you do it without simplifying it first, you should end up with the same answer at the end. And we know how sometimes it may not look quite the same and so forth. So let's just go with this one as a straight derivative. So we're going to do the outside, which means bring the 2 down front. We're going to leave the inside alone. To the first, times the derivative of the inside. Now this is going to be a quotient rule, right? So a quotient rule, we've got derivative of the top, negative sine, times the bottom left alone, so that's got to have parentheses, minus, I do not have enough room, I can see that. Okay, minus the top left alone, times the derivative of the bottom, which is negative cosine, all over the bottom square. Right? So, I see some things that could happen up here that might be good. Right? Yeah. So I'm going to distribute that. So that'd be negative sine plus sine squared. Right? And then here, is not going to turn into plus. And what's sine squared plus cosine squared? 1. So that whole top ends up being 1 minus sine x over 1 minus sine x all squared. So that whole inside, or that whole quotient rule ends up being that. So we end up with 2, and this is y prime, by the way, here. Somebody probably noticed it. And so this is 2, this is cosine x over 1 minus sine x, and then times 1 over 1 minus sine x, which I'd be okay with you leaving that, but you could just do that as 2 cosine on top and a 1 minus sine all squared on the bottom, isn't that? You could do that. This would be okay. Something like that. So that one did have a little bit of simplifying to it. And the reason I thought of that is I saw all these cosines. I thought, hey, I can multiply that as cosine squared. I could see a sine squared. Maybe sine squared plus cosine squared might come out of it. Now, it doesn't always. Sometimes you get sine squared minus cosine squared. That's nothing. I mean, that's just, you just have to leave that. But, so that one simplifies down pretty nicely. All right. What else? Was it? Did you have two of them loaded?
Yeah.
What was the other one?
Y equals another fraction. Sine of 2x over cosine of 2x.
Sine of 2x over
Cosine of 2x.
like that. That was it. Now again, on this way, evidently those are some, because that would simplify, right? To tangent, which means then I wouldn't have to do a quotient rule. You know, so tangent of 2x, so the derivative, so it'd be good to review just that. I'd probably give it to you as just that if I wanted you to do a tangent one, right? I probably wouldn't give it to you this way, but tangent of 2x, well, that's secant squared, leave the inside alone, times the derivative of the inside. It should end up being that, right? Which is the same as 2 over cosine squared, right? So that would be, now you wouldn't have to write it, you can write either of those, 2 secant squared or 2 over cosine squared. Now let's do a quotient rule on this, okay? Let's just say, hey, we didn't notice that, so let's do a quotient rule. So derivative of the top would be 2 sine 2x, right? We're kicking out the derivative inside, times the bottom left alone, minus the top left alone.
You don't have to do cosine.
Oh, I didn't just, yeah, thank you. That was, see, it's that kind of stuff that just can get you too. That's why, you know, when I was talking about how much you want to practice and stuff, because to get 8 out of 10, it's not always about that you know everything, right? That you know everything cold. You're going to make some silly mistake that's probably going to count for 1 that you're going to miss. You know what I mean? Let alone if you got a couple you don't know the rule on. So that's another, like right there, I just showed you. So, which I did on purpose, obviously. All right, top left alone times the derivative of the bottom, derivative of cosine is negative sign, so it's going to turn that to a plus, and we're going to be kicking out a 2 again, so there's going to be a sine 2x, and then all over the bottom squared. And of course, that's what happens. It's nice here. This ends up being 2 cosine squared plus 2 sine squared, right? And so you take out a 2, and you get cosine squared plus sine squared, which is 1. And so that's why the top ends up being just 2, and the bottom ends up being just that. That's what it is. So, good practice, though, just a quotient rule. Again, we've done 2 in a row where you have to simplify, and there was one I wanted to do. We were talking about it in here this morning. I think it's number 30. Somebody had, it's number, shoot, I can't find it. It was one that had some simplifying that I thought was a good one. Oh, yeah, 39. 39. Let's take a look at that one. On page 195, it says y equals log base 2 of, and then it's a cube root, so that'd be a 1/3 power. So then it's x e to the x to the 1/3 power. Now power on a product like that, you could put the power on both parts if you wanted to, or you could just leave it on the outside. A lot of times people just leave it on the outside because they're afraid of rewriting it and making a mistake or whatever, so that's fine. So where do we start with this one? Derivative of the log. So that's 1 over. Log is always 1 over, right? The inside. Times 1 over ln of 2, that's just the rule for log of another base. If it was ln, we wouldn't worry about that, right? If it was a natural log here, because we'd have 1 over ln e, which is just 1. And then times the derivative of the inside. And the derivative of the inside is going to be potentially a mess, because there's kind of a product rule in there. The x e to the x is a product rule. and you got this 1/3. So now we're just going to do this red. All we're worried about is this red part, right? All we're worried about now is the derivative of the inside. So that's going to be what? Bring the 1/3 down, x e to the x to the negative 2/3 times the derivative of that inside. Now we're looking at the black part right there. And now we're looking at a product rule. So derivative of the first is 1, e to the x left alone, plus x left alone, derivative of e to the x, e to the x. So now we got to kind of make sense of that. So so this is where you step back and say, okay, could I simplify this? Well, we've got this thing times this thing. Now you look at this, you think, is there a distributive here? Not really, because I got one thing, two things, times, and then I got a third thing times a fourth thing. So it's really it's like A times B times C times D. So this outer parenthesis here really is not, it turned out to not be necessary. Now this red parenthesis is here because of that plus sign. So I got to kind of keep this all together, okay? But since I have 1, 2, 3, 4 things multiplied, I could take this negative power and just flip it down. Now what you got to be careful of is when you have like an x plus x to the negative 3, you can't just flip that down under there because of that plus sign. But if you've got x times x to the negative 3, you can. So you got to be a little bit careful with some of those things that you do. You got to think about your rules for algebra. So I could flip this to the bottom, the 3's on the bottom, that's on the bottom, that's on the bottom. So the only thing on top is this one. So I'd end up with an e to the x plus x e to the x on top, right? And the bottom would have a 3, an ln2, and it would have an x e to the x to the 1/3 and an x e to the x to the 2/3. That's just x e to the x to the first, right? So that ends up being just that, and I'm still actually not done. Because what can I do on top? I can take out a e to the x. And then I have 3 ln2 x e to the x, and then that would cancel that. And so I actually end up with 1 plus x over 3. I'd put the x maybe in front, ln2, whatever. Whole thing, that whole big mess ends up doing that. Now again, we're spending a fair amount of time here on ones where you can do some simplifying, but most of the time that's not going to happen, right? A couple of times out of the 10, I don't know, what's a few, 3, 4, somewhere there. If you're doing it half the time or more, thinking of trying to find things to simplify, you're doing it too much. Okay, probably not going to happen that often. But there are some where you might be able to factor something out or be able to put some things together. Okay, and again, the reason I looked at that and thought I could is I saw this to a power and this very same thing to a power. So it looked like I could put those together, just like if I had an x squared times an x cubed, I'd want to write x to the 5th. Right? I want to put those together. So, all right. So anyway, somebody asked about that one this morning. I thought that's a good one to show for simplifying. Anything else that you've run into or seen? We haven't done many. Well, chain rule's a big one, right? You always got something on the inside, so you got to do that. And you got to do that correctly. Do it with that product rule, quotient rule. Make sure you're doing those. And then otherwise, just memorizing when you see the function, you know what to do, like an arc sine or an arc cosine. Anything? Okay. Now, you may have some individual questions. I can't really think of anything we haven't covered yet. I mean, obviously, or that really I would want to re-emphasize. Just be careful with the small mistakes. So the rest of the time I have for you to work together, work on your own or whatever, practice. Okay. All right. So again, this third website I gave you, it looks like it's got some good ones. I don't think they're overly difficult, but that's pretty good. Maybe get your confidence up. A good one for your confidence, maybe. Then if you get them wrong, I guess that'd be bad, right?
Oh my God.
You know, I mean, I know I've only looked. I just found it. I've had this before, but I didn't put it on my website, and I found it again. I thought, that'd give somebody some other places. All right. Go ahead and do it. Yeah.
So, tips to this type of stuff.
Yeah. Right. Well, the algebra things that happen the most, I think, are, you know, when you do the derivative of an inside, and so you've got, well, here, like, that you remember these parentheses, right? So we're going to multiply, remember, chain rules always multiply by the derivative of the inside. And then, so when I do that, I put a set of parentheses. And understand that if I'm going to have an addition in here, that I might have to distribute, or I at least have to keep this group together. Here, when I did the derivative of the inside, of course, it was a quotient rule, so that was different. The other two algebra things I think happen the most are when you just have to multiply numbers together, or you've got like an x to a power times another x to a power. So putting things together that can be multiplied together, I think that's one thing. And then the other algebra thing that happens the most is when you can factor out. So combining things that need to be combined, and where you can factor and cancel something. Now, the factoring and canceling almost always happens when you have a fraction, right? You got to have a fraction or you can't cancel. So here we ended up with a fraction because we had a 1 over with a log, or we have a quotient rule, right, or something here. So, other than just practice a bunch of problems and then bring them up to me, and if you're saying, hey, I think maybe I can reduce or cancel or do some algebra, or can I, whatever, that's fine. Okay. Okay? All right.